Hi, my name is Yash. I go to Westmont High School, located in Campbell, California, and I'll be a rising senior this year. Today I'm going to be talking about my second milestone in my object detection through machine learning on a Raspberry Pi project. And the reason why I kind of chose this project is I really like computer vision and I like what it does and how neural networks are able to use it to identify objects. And so what I did in my second milestone was train my own model to be able to recognize the difference between an Apple and an Android phone. And I did that through two separate ways. One, I used a pre-trained model, and the second way I did it was I trained it myself. And the pre-trained model was through something called RoboFlow. I just had to insert the pictures in, and it was able to do all the neural network computation to be able to train the model. And it was able to detect an iPhone and the Apple logo, and it can do the same thing for an Android phone as well, like the Google Pixel, OnePlus phones, or Samsung. And then the second way was through training the model myself on Google Colabs. So the model itself needs data. And the way I did that was I used a scrapper program that I found on GitHub, and I downloaded it, cloned the repo, and then utilized that program to download the top search results for iPhones, Google Pixels, Samsungs, OnePlus phones, and saved them onto my computer. And it downloaded over like 400 images. I then uploaded all those images into RoboFlow, which allowed me to essentially label those images. So for a model to understand what an iPhone is, what an Android phone is, those images need to be labeled of where the phone is in the image. So I could go through all 400 of those images and label them. And then once I did that, RoboFlow will automatically train a model to be able to recognize those phones. And it works out pretty well. The first test that I did, it came out to 78% accuracy, so it was very accurate even on its first training. I then wanted to expand that training model to be able to be even more accurate, and so what I did was I wanted to change the images by rotating them or copying them and cropping them and that type of stuff, and that type of stuff is called augmentation. It allows you to essentially have more images than you really have. So say if I downloaded 400 images, when I augment those images, I can have up to 12,000 images just by changing those images slightly and creating copies of them. So in my second trained model, I had over 1,000 images as compared to the first model where I had over 400 images. So the amount of training data that the model had was much more. And then additionally, what I did was I used something called transfer learning. I let the model learn what it did on its last training session to figure out new methods and build on old methods for detecting the phones. And this not only saved time in the newer training session, but also made the model more accurate. And that the end result was that in the second version of the model, it became around 90% accurate, which is about a 10% increase. And then another thing that I wanted to do was also train my own model myself, like personally do it, instead of letting RoboFlow try to train it. And I still used YOLO 5, which is the You Only Look Once program on GitHub. And I used their training program to do that. And what I did was I took all those labeled images on RoboFlow, and then I used their API to download them and store them. And then I would call the train.py program on YOLO 5. And then when I'd run that, it would be able to train the images through Google Colabs. And the reason why I did it through Google Colabs is because I needed a GPU, and I didn't really have one at the moment. So Google Colabs provides a free GPU for me to use. And then the result of the training was this right here. You can see that it was able to recognize the images relatively well. It's less RoboFlow, which is 78 all the way to 90 on the second version. So it's much less accurate because it's not on your computer, and I have to give it less images because it can't handle that much. But at the same time, it was quite effective. So that was a pretty cool thing I did. So some of the challenges with this second milestone in particular was downloading that many images. And the reason is like once you get to a certain amount of search results, like the images aren't going to be any better. So like that's the reason why augmentation was so important, because it allowed me to copy the images that I got that were good images, and then be able to copy them, manipulate them, and create more data. And then additionally, I was also able to. I had problems with doing the processing. I originally wanted to do it on the Raspberry Pi itself, but since I didn't have a CPU or a GPU, it didn't really work out that well. So I had to do it on the computer, and that's why Google Colabs was so important. So that was my project. The next steps will be people do like lifetime computer vision tracking and stuff like that, and with no lag on the Raspberry Pi. So that's what I look forward to do.